All right, ladies and gentlemen, welcome to a new video. In this video, we're going to be looking at our ESSRT page number 19, the bottom part. Now, that reference table page shows us the cross-section model of the Earth's lower atmosphere. Now, emphasis on lower and on the word atmosphere. As we know, the atmosphere is layers of gases, all right, surrounding the Earth. So it's layers of gases surrounding or going all around the Earth. Now, this graph has a y and x axis. On the x axis, we find latitude. If you remember what we learned about latitude, the first line of latitude is the equator, and then all the way to the North Pole, and then we also have the South Pole. We're going to do a quick review on that as well. On the y-axis, we have the word altitude. Altitude simply means height or elevation, to go higher in elevation. All right, so take note of these little things here and there. I'm going to bring them all up together. You would also find this letter H here and H here. This simply means high pressure. And the L here and the L here means low pressure. We're going to talk about that as well. J here stands for jet stream. J here also stands for jet stream. Okay, so let's take a dive into what that page is all about. So here we have the Earth, and surrounding the Earth is all of these layers of gases. So all of these are the atmosphere. So the atmosphere has layers. The first layer is referred to as the troposphere. Next to it is the stratosphere, and then mesosphere, thermosphere, and then finally we have the exosphere. Exosphere simply means you're already outside Earth. You're already in space. You are officially in space. Okay, so now let's come back down to the Earth's surface. The first layer is the troposphere. In that troposphere, that is where we have all of our weather, which is what this unit is focusing on, right? This unit is all about weather, the rain, snow, wind, and every other thing that we've discussed so far. So all of the weather, as we know it, happens in the troposphere. This is because the troposphere has the highest amount of water vapor. So the troposphere has all of the water vapor. Remember, our weather is driven primarily by the presence of water. Snow is water, wind is water, rain is water. So the presence of water vapor is what really creates an atmosphere for us. It's what really creates the weather for us. Okay. All right. Now, also take note, as you move away from the Earth's surface into space, the elevation is increasing. All right. The height is increasing as well. Okay, with all of those pieces of information, let's bring that into the Earth Science Reference Table, page number 19, the bottom part. Now we have here the troposphere. This tells you that this is the layer that is right above the Earth's surface. It's a layer that has the oxygen that we breathe in. It's a layer that has all of the water vapor that we are experiencing. So we can annotate that and say this has a lot of vapor. Okay, and then within the troposphere, as you go higher in height, you get cooler in temperature. So we can say temperature decreases as you go higher in height. As you go higher in elevation, temperature is decreasing. So you need to annotate that in full. All right, temperature decreases as you go higher within the troposphere. Now, directly above the troposphere is the stratosphere, and that is the layer that contains the ozone layer. So the ozone layer is right on this layer of the atmosphere, referred to as the stratosphere. Separating the troposphere from the stratosphere is the tropopause. All right, tropopause, which means the troposphere has ended. The troposphere is pausing, it's taking a pause. So this is where it ends. All right, cool. Now observe, if you will, that to the left side, the altitude is in kilometer, while to the right side, the altitude is in feet. So that is a very clear distinction you need to bear in mind. All right. Now, with all of that, we're going to talk about how the weather is created. Remember, we said hot air rises and cold air sinks, and then we have convection current, and that's what creates convection current. So when the hot air, when the sun is out and the hot air is rising, okay, it creates a low pressure, which means pressure is not on the earth's surface. So around this region will be a uppercase L, which means this is a low pressure area. Why? Because the air is rising, because the air is hot, so it rises. So as it rises, it goes up higher and higher. And then remember, within the troposphere, as you go higher, temperature decreases, which means the higher you go, the cooler it becomes. So as the hot air rises, creating a low pressure, when the hot air gets to a particular height, it's cooled down by the lower temperature, and all of that would form the clouds. The opposite is true on the right-hand side picture. Cold air sinks. So cold air sinks. So as it sinks, as it goes down, it gets heated, it gets warm, and then it moves that way. So because this air is sinking, it's going to create a high pressure. So we're going to have uppercase H here, creating a high pressure, which means the air is going down, is pushing down on the Earth's surface, thereby creating a higher pressure within that part of the Earth or within that Earth's surface, hence high pressure. Now, bringing that thinking into the diagram, here you would see that around the equator, because the equator is hot, you see that the hot air is rising. The hot air is rising. So if you want to annotate that, hot air rising, hot air rising. Make sure you're doing this beautifully. It should be more beautiful than I'm doing. All right. The hot air is rising, thereby creating a low pressure. So you can annotate that L as low pressure. Now, the opposite is true when you come to the H, the high pressure. You see that the cold air is sinking. So you should know that this air is cold or is cool. So because it's cool and cold, it's going to go down. It's going to create a high pressure. It's going to sink. So this air here is sinking as opposed to rising, creating a high pressure there. Same thing happens here. We see the air rising, creating a low pressure, and same thing is happening right here. We see the air sinking, creating a high pressure in the North Pole. So why is that? We've learned this before, that around the regions around the equator, that is where the sunlight focuses intensely on. All right. So for that reason, this part of the world is hot all year round. So it's called the tropical zone. It's hot. So because it's hot, the hot air is going to rise. Okay. So the hot air is going to rise around the equator, which is 0 degrees. Now, the opposite will be true in the North Pole. In the North Pole, the air here is cold. So the cold air would what? Sink. So the cold air sinks because it's cold. Since it's sinking, it's going to create a high pressure. And over here, since the air is rising around the equator, it's going to create a low pressure. So we're going to bring this back into the reference table here. So around the equator, right around here, this is going to be 0 degrees. Around the North Pole, this is going to be 90 degrees. And because it's 90 degrees and it's the North Pole, it's going to be cold. Around the equator, 0 degrees is going to be warm. And because it's warm, the air is rising. So we're going to say rising air here. So the air is rising. Because the air is cold in the North Pole, we're going to say air is sinking here. Air sinking over here. All right. So that is what is creating the low pressure and the high pressure region we have in this diagram. All right. So what happens is that as the hot air rises, because the equator is hot, a lot of evaporation is taking place. A lot of vapor is created, and the vapor begins to rise due to the low pressure. So as it rises, creating a low pressure, the vapor goes up, and the higher you go, the cooler it becomes. So the vapor forms the clouds that we see as a result of the cooling. So around the equator, we're going to have a lot of clouds, thick clouds. for that matter. So wherever the air is rising, it takes vapor along. It takes the vapor along to create the clouds. So here in the low pressure, we're going to have clouds here as well. So these two regions where we have low pressure are cloudy environments. So these regions are the wet zones of the world where we have a lot of rainfall, especially in the tropical region where around the equator, there's going to be a lot of continuous rainfall in this region. All right. Now, in the high pressure region where the air is sinking, we see that there are no clouds there. So these regions are dry. So this region with high pressure, they are dry. In fact, that is where most deserts of the world are located. So these regions are deserts, including the North Pole. The North Pole is technically a desert, a frozen desert. We're going to learn more about that when we get to climate. Okay, all right. So I think pretty much we kind of hinted on almost everything on this page. Don't forget how to use the altitude both on the left and on the right. Next, we'll talk about the jet stream. So the jet stream is the region is a transition zone between one region of the earth versus the other. For example, between the tropics and the temperate region, you have the subtropical jet stream. This is because it's close to the tropics, so it's subtropical. Now, this is called polar front because it's close to the North Pole. It's close to the pole, so it's polar front. Now, both of them are jet stream. The difference here is that one is closer to the equator, the other is closer to the North Pole. We're going to learn more about this jet stream later on as we proceed. Pretty much that is it. Let's try to use these reference table to answer some questions. Question number 1. Most of the water vapor in the atmosphere is found in the, remember, atmosphere simply means the layers of gases. All right, it's the layers of gases surrounding the earth. Now, those layers have different names. You have the troposphere, the stratosphere, the mesosphere, and then the thermosphere. So this question is asking, out of all these layers, which one has the highest amount of water vapor? We already annotated this before and we made it clear that the troposphere is the one that is closest to the Earth's surface, and bulk of the Earth's surface is covered by water, which is the ocean. The ocean occupies about 70% of the Earth's surface, the oceans. So a lot of the evaporation takes place from the ocean and from the land and from the trees. And all of this puts vapor into the immediate layer of the atmosphere where we live. And that is the troposphere, where we have a lot of vapor. So the layers of the atmosphere that has the highest amount of water vapor will be the troposphere, option C. All right, easy peasy. Question number 2. The temperature zone layer of the Earth's atmosphere is shown. Which temperature zone layer of the Earth atmosphere is shown in the picture, I think. So we have this diagram right around here, and this region is right around the 0 here is the equator. So if that is the equator, this is a 30 degrees and 30 degrees north and 30 degrees south. And we see that the air is rising and the air rose all the way to 10 kilometers. So it's asking which layer of the atmosphere is shown here. It rose all the way to 10 kilometers. So if I recall correctly, we're going to use the right hand side of the altitude. So I put the reference table page here. About 10 kilometers, when we are right around 10 kilometers, we see here that we are still within the troposphere. We are still within the troposphere. So all the way from the Earth's surface all the way to 10 kilometers, we are still within the troposphere. So our answer here definitely will be the troposphere. Question number 3. If the base of a cloud is located at an altitude of 2 kilometers and the top of the cloud is located at an altitude of 8 kilometers, this cloud is located in the, again, it's asking us which of the layers of the atmosphere is this cloud located in. First of all, it's a cloud. The cloud exists in the troposphere because that is where we have all of the water vapor. Above the troposphere, we barely have any water vapor. So there's no water vapor in the stratosphere. There's no water vapor in the mesosphere. There's no water vapor in the thermosphere. So all of our weather, the vapor, the rain, everything happens within the troposphere. Okay. So our answer here once again will be the troposphere only. How do we know? It says 2 kilometers to 8 kilometers. So 2 kilometers starts around here. This is 0, this is 5. So 2 kilometers will be right around here, 2 km, all the way to 8 kilometers. 8 kilometers will just be slightly below 10 kilometers. So this will be 8. So all of those layers still belongs to the troposphere. All right, let's move on. Question number 4. At 4,000 meters above the Earth's surface, the temperature of the cloud would be. So we have here, this is the Earth's surface, and the higher you go, the cooler it becomes. So we see that temperature started at 32 degrees Celsius, and the temperatures dropped about 10 degrees Celsius to 22 degrees Celsius. And then as you move further, the temperature just keeps dropping and keeps dropping, because within the troposphere, the higher you go, the cooler it becomes. So at an altitude of 4,000 meters, so this is the height, this is the elevation, so this is 4,000. So at an altitude of 4,000, what is the temperature around there? So as we go higher, it should get colder. So if this is 2 degrees already, then this should be something less than 2 degrees. So 3 degrees is not less than 3 degrees. My option 4, I can't really see that, but I think it's a positive, so I will also take that out. Now we are left between negative 3 degrees Celsius and negative 12 degrees Celsius. Now we have that at 5,000 is negative 8 degrees Celsius. So it has to be a number that is greater than 8 degrees Celsius. Negative 12 degrees is too low. It has to be a number greater than that. So it cannot be negative 12, because negative 12 degrees will be something way above that 8, because temperature is reducing as we go higher. So our answer stands out to be negative 3 degrees Celsius, and that will be the average between 2 degrees Celsius and negative 8 degrees Celsius. Last question. The direction of wind shown in the diagram is probably due to air moving from areas of. Now, what causes wind to move is air moving from a high pressure region to a low pressure region within the earth. So air would always move from H to L, from a high region to a low region. If that is true, our best option here is out, C is out. Air would always move from a high pressure to low air pressure areas. Looks like B. High humidity to low humidity, no. So our option here is B. So this is how you're going to be using this reference table ESSRT, page number 19B, which is the bottom part. See you in the next video.